All right, guys, so our first problem for this new solutions-based web tool is this one. We have two lead balls tied together and suspended from a pulley. So the situation might look sort of like this. One of the balls has a weight of 40 newtons, and the other has a mass of 10 kilograms. And we want to know that if they're released at the same time, what will their accelerations be? So we're going to go to another slide, and we're going to work out this problem and show you how the easiest way to do it. Again, remember the picture. It's always good to have a picture. So this one over here is 10 kilograms, and this one here is 40 newtons. We need to know the mass and weight of each ball. And remember, to do that, weight equals mass times gravity. Mass times 9.8. So the weight over here on the 10 kilogram ball side is 98 newtons. And the mass on the 40 newton side would be 40 divided by 9.8, which is 4.08 kilograms. So now that we have the weight and the mass on each side, we need to figure out the net force. Because the most important equation in physics, I've said over and over again, is F net equals ma. We're trying to find A. So acceleration is going to equal the net force divided by the mass. And that's the total mass, the mass of the system. So for as far as net force goes, over here we have 98 newtons, and that's pulling down. Over here we have 40 newtons. That's also pulling down. But the 98 from the left side, over here on the right side, because of this pulley, is pulling up. And the 40 from the right side, over on the left side, is also pulling up. So you should be able to see that on each side, we have a net force of 58 newtons. That net force is going to cause both of these balls to accelerate. So to work out the problem, A equals F net over M. A is going to equal the net force of 58 newtons divided by the total system mass, because that force is acting on both masses. So the total system mass is 10 here, 4.08 here, a total with three significant digits, we're just going to say a 14.1 kilograms. So if we do the math on that, 58 newtons divided by 14.1 kilograms, we end up with an acceleration of 4.11. Now in terms of your units, remember that a newton is a kilogram times a meter over a second squared. We're dividing that by kilograms on the bottom. So when we do, you should be able to see that the units are meters per second squared. For the ball on the right, it's going to be accelerating upward. So that would be plus or upward 4.11. And for the ball on the left, that's going to be accelerating downward. So we could put negative, or we could say 4.11 meters per second squared downward. Hope this helps. All right, here's problem number 2 on our new web-based system. A balloon is attached to a set of instruments with a mass of 8 kilograms. We're assuming that's the mass of the balloon and the instruments. And that balloon exerts an upward lifting force of 150 newtons. And we want to know the rate of acceleration. So our picture might look something like this. Here's our balloon. Here's our instruments. Together they have a mass of 8 kilograms. The balloon is exerting a 150 newton upward buoyant lifting force. We want to know the acceleration. We've got to remember that F net equals ma, and therefore acceleration equals F net divided by mass. Now a lot of you are going to plug in 150 for F net and 8 for mass and think you've got the correct answer. You would not have the correct answer if you did that, because the weight that we've got to take into account is the weight of all these objects. Remember, to find weight, we're going to go mass times gravity. So we'll take the 8 kilograms of mass times 9.8 acceleration due to gravity. and this is 8 kilograms. So if we go 8 times 9.8, we get a weight of 78.4. And that's kilograms times meters per second square, which is newtons. That weight always acts down. So we have 150 newtons acting up and 78.4 newtons acting down. If we subtract those two from each other, we end up with a net force of 71.6. And it's 71.6 newtons acting upward. That is the force that causes our acceleration. So to find acceleration, A equals net force, 71.6 newtons. I'm going to write the newtons this way so that we can see our unit cancellations. That's what a newton is. Divided by mass. The mass of our object, 8 kilograms. Now you can see that the kilograms cancel. Let's go ahead and divide that out. When we do, we get an acceleration of 8.95 meters per second squared. And a good thing to add to this would be up, where this is accelerating upward. Our balloon is going upward. All right, now let's look at part 2 of the same problem. Part 2. If the instruments accelerate upward for 20 seconds, and remember, they're accelerating during that time at 8.95 meters per second squared. Up. And then they're released. How fast are they going at the moment of release? Now we're assuming in this problem that we're starting off with an initial velocity of 0. So we're looking for a final velocity. So again, here's what we know. We know acceleration is the acceleration due to gravity. I'm sorry, it's not the acceleration due to gravity. The acceleration in this problem is the acceleration caused by our balloon, which is 8.95 meters per second squared. We're starting off with an initial velocity of 0. We're accelerating for 20 seconds, and we're looking for a final velocity. So I'm hoping that you can see that VF equals VI plus AT would be a nice equation for us here. And that VF equals 0, our initial velocity, plus 8.95, our acceleration, times t, 20 seconds. If we do the math on that, 8.95 times 20, we end up with a final velocity of 179 meters per second, and that is in the upward direction. So that would be our final answer on part 2B. Hope that helps. All right, guys, so here's force question 3. We've got a 40 kilogram mass sitting on a table. It's attached via a rope and a pulley to a 20 kilogram mass that's hanging off the edge of the table. We want to know the acceleration of both masses as soon as we release the 20 kilogram mass, assuming that there's 10 newtons of friction acting between the 40 kilogram mass and the table. First thing we need to do is draw a picture. And the picture might look something like this. Let's draw a table first. We have the 40 kilogram mass sitting on the table. It's attached up via a rope. And let's put in a pulley right here. This will be our pulley. To the 20 kilogram mass. It's hanging off the edge of the table. Now we know that when this is released, the 40 kilogram mass is going to move in this direction. But there's also some friction. Friction always acts opposite of motion. And in this case, the force of friction, we'll call that FF, it's 10 newtons. Now we also know that to find acceleration, F net equals ma, which means that acceleration equals F net over m. So we need a net force. The 10 newtons is not a net force. The force that's making these two masses move is this 20 kilogram object falling. But kilograms don't measure force. They measure mass. So to convert 20 kilograms to force, we need to go weight equals mg, weight to force. So if we go 20 times little g, which is 9.8, acceleration due to gravity, we end up with a force here of 196 newtons. And that's not 19.6, that's 196 newtons. That 196 newtons pulls the 20 kilogram mass down. It also moves the 40 kilogram mass to the right. So we have 196 newtons pulling that way on the 40 kilogram mass, but we have 10 newtons pushing toward the left, which should tell you that you have a net force of 186 newtons. And that net force of 186 newtons acts on both masses. So when we get ready to solve for acceleration, we're going to say A equals F net 186 newtons, which I will write this way, because that's what a newton is, divided by the total mass of the system, the total mass that this force is acting on, which is 20 plus 40, 60 kilograms. So when we solve that out, 186 divided by 60, we end up with a net force, an acceleration of 3.10, and we can see that the kilograms cancel. So our units are meters per second squared. If we were talking about for the 20 kilogram mass, we could say 3.10 meters per second down. If we were talking about the 40 kilogram mass, we could say to the right. But our correct answer again is acceleration is 3.10 meters per second squared.